Welcome all to this brief introduction about how to program field programmable gate arrays. So you can program FPGAs using static RAM programming technology, EPROM or EEPROM programming technology, or anti-fuse programming technology. So in this presentation we will see about static RAM, but we will have a brief introduction about EPROM and EEPROM and anti-fuse technology. EPROM is nothing but electrically programmable read-only memory, and EEPROM is nothing but electrically erasable programmable read-only memory. So you will have to apply some voltage. So if you take the electrically programmable read-only memory, this is the structure. This is called control gate. This is called floating gate, and this is drain, and this is source. So by applying various biasing conditions, you can have the floating gate can have charges on it, so that is called as programming. And if you want to erase the content on the floating gate, then you will have to apply what is called UV light for erasing it. So for programming, you will have to apply sufficient potentials on the control gate, drain and source. But for erasing it, you will have to apply UV light, and that is the problem with EEPROM technology. And it is also called floating gate MOS transistor, shortly called as FAMOS. And EEPROM is called as, again it is also the same similar technology, where you have a threshold voltage, because when charges have been deposited on the floating gate, the threshold voltage is going to increase. So due to that problem, we are moving to the EPROM technology, as well as you can electrically erase. So programming is done by applying cohesion condition, and if you want to erase the content stored on the floating gate, then you will have to apply sufficient potentials on the terminals to erase the content. So both are programming and erasing are done in the electrical, or what is the potential applied on the terminal. So it is called electrically erasable technology. Third technology is called anti-fuse programming technology. So normal fuse is called when sufficient current is passing through the fuse will be okay. When the current exceeds, then the fuse is going to break. The other way, anti-fuse is opposite to it. So the anti-fuse method closes the switch, closes the circuit by growing a conductive path. So when you want this logic block and this logic block, so logic block is nothing but it is going to realize some logical function. When you want to, so this is A and this is B. So if you want a connection between A and B, then anti-fuse could be used, and it could be programmed by applying the programmed current. So using this current, you can make a connection, and that is called as anti-fuse technology. So it is opposite to regular fuse. So whenever you need a connection, you apply some programmed current to it, and then you get the connection, and this is called what is called as anti-fuse. So we are into static RAM. So we take this as a logical modular logical block, and this is the next logical block. When you want to have connection between A block and B block, there is a transistor present between logical block A and B. So this transistor is nothing but a pass transistor. So whatever the gate is being connected to SRAM cell, and whatever it has been stored, it is called, suppose the cell can store a logic value of 0 or 1. So this 0 or 1 is called configuration bit. So depending upon the configuration bit, the connection will be established between block A and block B. Suppose if it is 1, this pass transistor is in on condition, so there will be a connection established between logical block A and logical block B. So this is how the programming has been done with static RAM. So static RAM programming technology involves creating reconfigurability by bits stored in the static RAM cell. So this bit, M is nothing but memory. So this M, it could be 0 or it could be 1. In this case, when M is 0, there will be no connection, because for 0, NMOS transistor will be in off condition, and for M bit to be equal to 1, when it is applied to the gate, then connection will be established between two logical blocks. So similarly, the logical block, IO block and interconnection or the routing can be made programmable by using configuration bits stored in SRAM cell. So reconfigurable logic block can be easily implemented using lookup table, which is same approach as that of your ROM, read only memory, which is one time programmable. 16 SRAM cell can implement any function of 4 variables. So similarly, you can program interconnects using SRAM, and this is not the last point says the bit that are stored in the SRAM for deciding the LUT to be functionality or interconnections are called configuration bit. So the whatever may be the value stored in in memory cell is going to decide whether you are going to have a connection or not. Next is we are going to SRAM cell. So this is SRAM cell, which is using 6 transistors, Q1, Q2, Q3, Q4, Q5 and Q6. So it is a cross coupled inverter. So this is inverter 1. So this is my inverter 1, and this is my inverter 2. So the output of the first inverter is fed to the input of the second inverter. So this is my output. So I am going to consider this as Q, and this Q has been fed to the input of the second inverter, and the output of the second inverter is again fed to the output of the second inverter is again fed to the input of the first inverter, and I am going to consider this as Q bar. So 4 cross coupled transistors are required to create a latch, and 2 additional transistors are required to control passing data bit into the latch. So Q5 and Q6 are called as, they are going to control or they are going to use used for program it, whether you are going to write or read from the memory cell. So you can call this Q5 and Q6 as access transistor. When the word line is set high, your Q5 and Q6 will be in on. The value of bit line will be latched into the cell, the value of bit line. So whatever may be the bit line value. So when bit line is 1 and bit line bar is 0, so this 1 will be latched to Q and 0 will be latched to Q bar. That is called as writing operation. The second operation is reading operation, is performed by pre-charging the bit and bit line bar equal to 1. So you should make this line equal to 1 and this line equal to 1, and then setting the word line high will read the content whatever is being present in the cell. The content stored in the cell will then appear in the bit line. So SRAM cell implemented using, you can also implement SRAM using 5 transistors. That is, you can avoid this Q6 transistor. Q6 transistor with only one access transistor Q5. You can either read or write from the memory cell. So what are the advantages? The advantages, it is volatile. So when power is turned off, the memory cell is not going to retain the value, and you can write new content again and again. So this provide flexibility using prototyping and designing. So that's why we are going for what is called as FPGA. Prototyping and is possible with the FPGA. So this SRAM is being used in FPGA. The major disadvantages of SRAM programming technology is 5 or 6 transistors are being used in SRAM. So if it is 6 transistor, your SRAM cell is going to use 6 transistor. This adds a tremendous cost to the chip. So 6 cell is going to use, suppose if you can build using DRAM where you can use single transistor. So this SRAM cell is going to use 6 transistors. Suppose for example if an FPGA has 1 million suppose if it has 1 million programmable points, 1 million programmable points, then it has approximately 6 million transistors are employed in achieving programmability. So that is the only so this 6 million transistor 6 million transistor is going to occupy more area. What is our objective of going to VLSI? Either I should obtain low power, high speed, and third point is I should have minimum chip size where area is important. So when you go for SRAM cell, then the area is going to be more utilized. So it is going to be the disadvantage of going to SRAM cell. And thank you all. Thank you.